This video, this is previous the tutor. We are going to look at absolute value questions and we'll be looking at tutorial. Welcome on board. So solve the following. Okay, question 1, modulus of 2x minus 5 is less than 7. Okay, so for this one we use this. If you have this situation, it's a just do this. You have x here, then we have b here. What this means is this: once you see less than here, okay, once you see what less than here, you're going to have the same, all right, and then the other one you just flip like this. This means that your solution x, all right, lies between b and negative b, like this. Okay, so coming to this, all right, it means our solution to x minus 5, all right, lies between 7. It also lies between negative 7. That's what it means. Okay, so step 1, take the negative 5 this other side. So if I take the negative 5 this other side, this becomes negative 5 plus 5. So negative 7 plus 5, here remains 2x. I take negative 5 also to the other side, I have 7 plus 5. So what do I remain with? I remain with negative 2 here, 2x. Here I will remain with what? 12. Now, what do we do? Divide throughout by 2, both sides, so that you only remain with what? X, as shown here. So divide here by 2, you remain with negative 1. Divide by 2 here, you remain with what? 6. Therefore, your solution is that x is actually in this range. That's all. If you want to do this graphically, okay, if you want to do this graphically, it's like this. So not graphically, but on the number line, you have negative 1 here, then you have 6 somewhere here. Of course, here we've got 0 somewhere there. So it lies like this. It's in between. Okay, your x lies in that area. Let's look at number 2. Number 2 is modulus of 3x plus 1 greater than or equal to 10. Now for this one, okay, you are going to have the same, then just flip the other one. Like that. Because of or, meaning your solution is a union. Okay, for greater than, your solution is union, like. But for less than or equal to, it's an intersection type of arrangement. Okay, this can also be written as, of course, we know this one to be the same, to be negative b, okay, less than or equal to x, less than or equal to b. But this one, it will be something different. Okay, it will be something different even when you show it by the number line. All right, so coming to the question itself, so we are saying we are going to solve it in this manner. Okay, we say 3x plus 1 greater than 10. All right, or we can say 3x plus 1 less than or equal to negative 10. Okay, so now we solve them differently. So this will give us 3x. This guy comes, the other side becomes 9, or 3x. This guy becomes negative 11, right? Exactly. Then divide throughout, you have 3, or you have x 11 over 3. So our answer is x is less than negative 11 over 3, or our x is greater than or or equal to what? 3. Of course, if you have to show this on the number line, okay, you have negative 11 over 3. You shade because all the numbers there are included. So you can see to say a number that are less than this negative 11 over 3, they are this side. And the numbers that are greater than 3, they are also this other side. So that your answer lies there, your answer also lies there. That's where your x is, and that's where your x is, not in the middle. You see that it's different from the one for and when it's less than. Okay? For less than, it's an intersection type of arrangement. But for greater than or equal to, whatever, whether it's greater than or greater than equal to, it's the same arrangement. It will always be a union. Okay? Meaning our answer in short, we are saying we are going to negative infinity, okay, comma negative 11 over 3. We include it union 3 to positive infinity, like that. Let's look at this one. Okay, it is greater than, so we're going to use the word or. So we have x minus 4 less than negative 6, or x minus 4 greater than what? 6. That's what you do. That's all. So you have x. Okay, if I take this for the other side, that becomes the positive 4, meaning I'm going to get negative 2. Or x, this side becomes what? Greater than 10. Our answers can end here, or you can say less than negative 2. It goes all the way from negative infinity to 2 to negative 2. Don't include them because there's no equal sign there. Then 10 to positive infinity. If you want to show this on the number line, it's very easy. Okay, just check where negative 2 is and check where 10 is. They are not included, so we use circles that are not shaded. So this side and this particular side. So this is the area, and that is the area where our x lie. Okay, just simple like that. It's about this one. Modulus of x minus 2 plus 1 greater than or equal to 4. How do we work out this one? So to work out this one, okay, we first have to take this one on the other side. So we have x minus 2, 4 minus 1. So we have x minus 2, get 3 there. Then we go back to the way we did when it was greater than. Once you see greater than, start thinking of all, meaning we have x minus 2 less than or equal to negative 3, or x minus 2 greater than what? 3. One of them is going to be maintained just like that. So if I take negative to the other side, that becomes x less than negative 1. Or if I take this guy, the other side becomes positive. It's x greater than 5. So our answer just lies there, here. Or you can say, well, less than or equal to negative. So, sorry, we don't include negative infinity, but this one is included. Union 5 positive infinity. And of course, if you try to sketch it, you'll be getting negative 1 somewhere there, and you'll be getting 5 somewhere there. They're included, so we shade. So there is this side and this particular side where our x lie. So it's simple and straightforward, just like that. Know the conditions. Know the conditions. The one that I gave you at the beginning, condition for this one is this. I also gave you for this one if you copied it.